Hello everyone, and welcome back to another devlog for Strong Compute Cluster Manager. We're finally back after a couple of weeks because we've been showcasing this interface to a lot of people and we've had some very good feedback. But just to talk about the features that we've been working on since the last one.
Before we dive in, Xander, which what number are we up to now?
We're up to 11 or 12, I think.
11 or 12. And we got
something, maybe I can double check.
And we've got Ethan with us here today.
Hello, it's my first time being in a devlog and I'm excited to be here. My name's Ethan and I'm working on mostly the 3D graphics as well as the UI and making it all look pretty and usable for the end user.
Thanks, Ethan. It's been a lot's happened since we last checked in. We got out to the AI Infra Summit in San Jose and got to show off this interface to a lot of people. It went over very well. There was a very positive reception. Xander and I were both there, and we're going to cover some of the things that got demoed at the AI Infra Summit, as well as some new things that have been worked on since then. All right, Xander.
All right. So the first thing I'll show is something that's a work in progress, and then I can take it away because it is a work in progress. We're working on visualizing networking. So something very important when you're organizing your infrastructure is making sure that all the nodes that are running a certain job can communicate at a good speed and not have to jump between a bunch of switches. So we're working on a way to visualize which nodes are connected via this kind of thing. We've got one layer going at the moment, but we need to show each of the sort of spines of the switch, like how many hops it would take to get from one node to another.
Sure. Now, to make your life easier, Xander, networks visualized by the system and almost the concept of a cluster itself, networking will only occur within a cluster.
For sure.
So that visualization showing connections between two different clusters and the ensuing complexity will not be something
definitely a work in progress. This is literally for getting
it's good. It's nice to know that it's still like digestible, even with that complexity.
We need to make sure that it is simple enough in how we display it that you can go, oh yeah, I can see what's connected. Yep. But yeah, if they're all within the same cluster, that makes it like a whole lot easier. Yeah, so that's perfect. Yeah, so let's we can get rid of this now because it is WIP. But there we go. So some other stuff we've changed is to do with the game. I'll talk about that and then I'll pass it to Ethan. Worked on the tutorials to make it a lot easier to get into the game. So the messages and the UI, you will notice from last time, the UI looks a lot nicer. We've got glowing bits to show you what you need to be doing. And of course, new mechanics such as the CFO getting angry at you if you've got hardware that's not being utilized. And as soon as that hardware is being utilized, he'll be okay with you and his patience won't be draining. Another thing we've got is the burst budget. So if you've got spare budget, that budget's going to start pooling up into a pool that you can use on burst so that your burst jobs aren't pulling out of your regular budget. It is just... yeah, now I've got about $90 I can spend on bursting if I need it later.
And so this is meant to help guide people into what is possible with strong compute. So historically, the way budgets have been managed is there's been sort of a fixed number of GPUs that are there for development. People are given a node or a workstation or something like that. Anything above that, there kind of has to be some kind of management discussion, some dialogue. There isn't sort of too much freedom, flexibility to work with. So the idea here is, if you're given a budget of $250 an hour, that's going to add up to some millions of dollars over the year. That's fine. If you block out, $500,000 worth of resources, you're still going to have a few $1 million left to work with. And so the idea of the burst budget is it's showing this is what you haven't spent, this is what you haven't reserved, and so you can go and use that for ad hoc capacity. So rather than having a fixed number of 512 GPUs for the whole year, you maybe have a fixed 128 GPUs for the whole year, but then you can access as you need a few thousand GPUs for a few hours or a few weeks, or however much kind of unspent budget that you've saved up. And this is to kind of stop people resource hoarding, to stop them being on resources that are always too big or too small, and instead allow you to kind of flexibly move those resources around to how many GPUs do you need today, this minute, this hour?
Yeah, absolutely. It's a lot more flexible. We just need a way to show people what is possible so they know how much flexibility they have. Is that right? Yeah, perfect. All right. Well, I'll pass to Ethan to talk about how we make all of that look really nice. So here you go.
Lovely. Thank you very much. Just take
Just be
control.
careful.
Just take
Yeah.
control here. Don't break anything. Make sure my mic's perfect. There we go. All right. So I've been doing most of my stuff by following user feedback. So we've done a lot of playtesting with new users over the past couple of weeks, sort of to whittle down and distill exactly what we need to work on. And one of the big things that was mentioned from users was being able to see information. So originally, and such is still the case, you can click on spaces, clusters, regions, and see the information here on the right. But we found that for new users, it can be quite difficult to figure out all this information and figure out what they actually need. So we've distilled it down to very, very simple labels that now appear on everything. So you might have seen earlier on jobs, they will show up on top of the box that shows up there. So let me just really quickly create a job, let's say of, 32 GPUs. And you can see that there is a label here that shows how many GPUs the job needs, as well as the amount of jobs available on the spaces.
So yeah, if we speed this up, you'll see it all change. There you go. Way easier to tell what you have available.
Yeah, that's right. It's way easier to very quickly at a glance see the amount of resources that you have, making it a lot easier and smoother to manage client jobs.
Yeah, and I noticed there's like a mini map in the corner. What's that about?
That's right. So another piece of feedback that we got from users was the size of the map. And even though it looks really good, it can be quite difficult to navigate, especially when you have a large amount of regions to work with. So we implemented a mini map. So this mini map accurately shows the amount of regions and infrastructure you have. So if I create some more demo assets, you can see the minimap updates in the bottom left here. It also allows you to click on it and navigate around super quickly, which makes just the whole gameplay experience a lot smoother.
It's very, very cool.
Thank you. Did you want to talk about some of the major gameplay changes that we've had?
We did.
I'm very excited about the minimap. I just want to jump in. This is really, really going to help a lot, especially as we start to transition to larger clusters. So here, obviously, we've got a representation that's just showing spaces, not specifically the node counts, but it's giving you a chance of kind of spatially how much resources you have. So a big part of how we design this interface is to let you think of, literally just physical area as the compute you have available. Now, right now, we have all GPUs of all types are all shown in the same size. We are going to experiment with some new ways of looking at GPUs. So the width of the GPUs, we're going to have a look at as representing the amount of VRAM. So how wide is your bucket? That's the size of the thing that you can put into the bucket. And then how deep your bucket is, how sort of tall, so kind of up and down the screen, the GPU is how performant it is. So that's how quickly the workload's going to get processed. And obviously, different GPUs are slightly better at, different kinds of workloads and that kind of thing. So we'll probably just go, around some kind of, standard base reference of FP16 performance in terms of the flops that we're using for the height of the GPU. But the idea here is that, where do I have capacity? Where is it free? Where am I going to get my work done? Well, the height's going to get it done faster. The width is going to make it possible to run. That's how I can go and see where work can happen.
Yeah, so that's the sort of current trajectory we're going to be looking at for those. Also post-processing and a couple of visual fidelity changes, performance enhancements, at least on my end.
Yeah, for sure. And another big thing we're going to have to work on is what happens when you have thousands of these GPUs. So we're going to increase sizes in different dimensions to show, speed and capacity. But now what happens if you're going to have like 1,000 GPUs in one area? You're going to end up with a really, really tall section, and we need to find a way to aggregate it down into a way that still communicates the physical space it takes up, but doesn't like overload you with just a bunch of rectangles.
Mm-hmm.
That's the next problem as well.
Yeah.
All right. Really, really good progress.
I
Good
agree. Thank you.
Awesome. And remember, you can come and play test. Just go to strongcompute.com/cc. Yeah, we've also the game is now called Clustercraft. That was the other.
Clustercraft.com.
We registered the name finally.
Yes.
Now we're going to call it, yes.
All right. Well, thank you for this week's update, and we'll see you next time.
We shall see you then. Thank you for watching.